Hello students, so we are doing exercise 21C, prove trigonometrical identities, isn't it? So we have finished till question number 5 in our previous videos. So today we'll start from question number 6 onward. Okay, let's begin. A triangle ABC is right angled at B. Find the value of sec A into cosec C minus tan A into cot C upon sin B. So before solving this question, let us first understand the angles of a triangle. Okay, suppose this is a right angle triangle. First let us understand the triangle. This is A, this is B, and this is C. Now if you are talking about this angle C, then at this time your perpendicular will be AB and base will be BC. This will be base, this will be perpendicular. Okay, if you are talking about this angle, perpendicular will be this AB and base will be BC. Hypotenuse will be AC. Hypotenuse is the longest side, it will remain fixed. Okay, but if you rotate this triangle, or if you talk about this angle, okay, instead of talking about angle C, if you talk about angle A, if you consider angle A, then at this time your perpendicular will be BC and base will be AB. Are you getting me? Which means if you are talking about this angle A, perpendicular will be BC, base will be AB. And if you are talking about angle C, then perpendicular will be AB and base will be BC. That means depending upon the angle which you are choosing, the perpendicular and base interchanges each other, isn't it? If you talk about angle C, this becomes perpendicular, this becomes base. If you talk about angle A, this becomes perpendicular, this becomes base, isn't it? The angle associated with it, one side of it contains always the hypotenuse and the other side is always the base. Okay, and the opposite side is perpendicular. In this case, the angle, the adjacent sides are, this side is always the base and the other side is always hypotenuse. Okay, and the opposite side is perpendicular. I hope you got this. Now let us move to the question. Okay, now we have triangle ABC right angled at B, isn't it? So let us draw a right angle triangle. So let us draw a right angle triangle. This is a right angle triangle. Okay, right angled at B. This is B and this is right angled. So if this is B, this must be C, this must be A. While writing ABC, we must always write in the anti-clockwise direction. Okay, never in the clockwise direction. We must always write in the anti-clockwise direction. So if this is B, this must be C and this must be A, opposite to the direction of the clock. Okay, so since we know that sec theta means hypotenuse upon base, isn't it? Sec theta means hypotenuse upon base. So sec A, now I am writing the values. Okay, sec A means you are talking about this angle, isn't it? Sec A, hypotenuse upon base. Sec A, sec means hypotenuse upon base. When you talk about this angle, your hypotenuse is always AC, hypotenuse is AC and base is hypotenuse upon base. Sec means hypotenuse upon base, base is AB. If you talk about angle A, base will be AB, isn't it? Are you getting me? The angle which contains the two sides, the adjacent sides, one will be the hypotenuse and another will be the base. Okay, so sec A means AC upon AB, hypotenuse upon base, into cosec C. Okay, cosec means hypotenuse upon perpendicular, isn't it? So cosec C means this angle, angle C. Cosec C means this angle. When we talk about this angle, hypotenuse is always AC and the base becomes BC because the other side, the adjacent side, is BC. So hypotenuse is AC, hypotenuse upon perpendicular. Sorry, hypotenuse upon perpendicular. Cosec theta means hypotenuse upon perpendicular. So this is base means perpendicular is AB. So AC upon AB. Are you getting me? Now minus tan A. Tan theta means perpendicular upon base, isn't it? Tan theta means perpendicular upon base. So tan A means you are talking about this angle. So perpendicular is BC. BC upon base is AB, isn't it? Into cot C. Cot C means cot theta means base upon perpendicular. So if you are talking about this angle, so base will be BC, base upon perpendicular. Perpendicular is AB. Okay. Now in the denominator we have sin B. Sin B. Angle B is 90 degree. So sin 90. In the numerator we have AB into AB. AB square. And in the numerator AC into AC. AC square, isn't it? Minus BC into BC is BC square upon AB into AB is AB square. Okay, so in the denominator sin 90 means 1, so no need to write that number 1. Every number has 1 in the denominator, isn't it? So AB square and AB square, we take the LCM will be AB square. So in the numerator AC square minus, since the LCM are same, so this comes directly BC square, isn't it? AB square into 1 is AB square, that 1 into AC square is AC square, minus comes here. AB square into 1 is AB square, that 1 into BC square is BC square. Okay, so in the denominator we have 1, so needless to write that 1 because 1 is always in the denominator of any number. So we have AC square minus BC square. What is AC? AC is hypotenuse. Hypotenuse, isn't it? AC is hypotenuse. Hypotenuse square minus BC square. BC is perpendicular or base depending upon the angle you are choosing. Let's say base square. Okay. Hypotenuse square minus base square. This is hypotenuse square minus base square. Hypotenuse square minus base square is always perpendicular square, or hypotenuse square minus perpendicular square. Hypotenuse square minus perpendicular square is always base square. Hypotenuse square minus base square is always perpendicular square, isn't it? This comes from the Pythagoras theorem, since h square equals to p square plus b square. Now you bring this p square to the left hand side. H square minus p square equals to b square. You can do this either, or you can also do this. H square, bring this b square minus b square equals to p square. Perpendicular and base changes depending upon the angle you are choosing, isn't it? So AC square minus BC square is, AC means hypotenuse, BC means this perpendicular. So AC square minus BC square means obviously AB square. Hypotenuse square minus base square is perpendicular square. So let's talk about this angle. AC square minus BC square, hypotenuse square minus perpendicular square is base square, AB square, isn't it? So this can be written as, let me erase this, okay? Now AC square minus BC square can be written as AB square upon, we have AB square. So this AB square and AB square can be cancelled and answer is 1. Okay, I hope you got this. Now let us move on to the next question, question number 7. Okay, now let us do question number 1 of 7. So to solve this type of question, we need to know the values of sine 60, cos 30, cos 60, sine 30. Okay, we need to have a clear knowledge of trigonometrical table. I've already made a video, separate video for that. You can find the video in the playlist and watch the video. Okay, so let's do this. So we have sine x equals to sine 60, isn't it? What is the value of sine 60? Sine 60 is root 3 upon 2 into cos 30 is root 3 upon 2 minus cos 60 is 1 upon 2 into sine 30 is 1 upon 2. or sine x equals to 2 to the 4, root 3 into root 3, 3, minus 1 1 the 1, 2 to the 4, isn't it? Or sine x equals to 4 and 4 LCM. In the numerator 3 minus 1, or sine x equals to 3 minus 1 is 2 upon 4, 2 1 the 2, 2 2 the 4, or sine x equals to 1 upon 2, isn't it? 1 upon 2 means sine 30 degree, isn't it? Sine 30 means 1 upon 2. 1 upon 2 means sine 30, okay? Sine 30, 1 upon 2. Sine 30 means 1 upon 2. So you cannot cancel this sine, okay? Sine and sine are identities. Sine, cos, tan, cot, sec, cosec. These 6 are identities. We cannot cancel sine, but we can leave the sine, okay? So leaving sine from both the sides, x equals to 30 degree. This is the answer for x, okay? We are asked to find the value of x, and the value of x is 30 degree. I hope you got this. Question number 2 of 7. Find the value of x. We are asked to find the value of x from this equation, isn't it? So sine x equals to sine x. This is x, okay? Sine x equals to sine 60 means root 3 by 2 into cos 30 means root 3 by 2 plus cos 60 means 1 upon 2 into sine 30 means 1 upon 2, or sine x equals to root 3 into root 3, 3, 2 to the 4, plus 1 into 1, 1, 2 to the 4. So sine x equals to 3 plus 1, 4 upon 4, isn't it? LCM, or 4 1 the 4, 1. Sine x equals to 1 means sine 90 degree, isn't it? 1 means sine 90. Sine 90, the value of sine 90 degree is 1, okay? So you cannot cancel sine, just leave sine from both the sides. X equals to 90 degree. Okay, we are asked to find the value of x. Find the value of x, isn't it? So the value of x is 90 degree. I hope you got this. Question number 3 of 7. Okay, cos x equals to cos 60 cos 30 minus sin 60 sin 30. So we are asked to find the value of x, isn't it? So we have cos x equals to cos 60 means 1 by 2. And cos 30 means root 3 by 2 minus sin 60 means root 3 by 2 into sin 30 means 1 by 2. So cos x equals to 2 to the 4, 1 into root 3 minus this 1 into root 3 is root 3, 2 to the 4, root 3 into 1 root 3, 2 to the 4, or cos x equals to root 3 by 4 minus root 3 by 4, 0, or cos x equals to cos 90 degree, isn't it? The value of cos 90 is 0, okay? Or leaving cos from both the sides, x equals to 90 degree. So the value of x is 90 degree. Let's do question number 4 of 7, okay? Tan x equals to tan 60 minus tan 30, 1 plus tan 60, tan 30, isn't it? Actually, in the higher mathematics, there is a formula called tan a minus b. Tan a minus b is tan a minus tan b upon 1 plus tan a tan b. Okay? Tan a minus tan b upon 1 plus tan a tan b is tan a minus b. This means tan, what is a? A is 60, b is 30, isn't it? Tan a minus tan b, 1 plus tan a tan b. Tan a minus tan b, 1 plus tan a tan b, isn't it? Tan a minus tan b, 1 plus tan a tan b. This means tan a minus b, 60 minus 30, 60 minus 30, isn't it? So we have tan x here, tan x equals to this. So x equals to, leaving tan from both the sides, 60 minus 30 is 30, isn't it? We can find the answer. So simple, way, isn't it? In the so simple way, but this is not allowed here in class 10. Okay, we must put the values here. So this is tan x equals to, what is the value of tan 60? Tan 60 is root 3 minus tan 30 is 1 upon root 3 whole upon 1 plus tan 60 means root 3 into tan 30 means 1 upon root 3. So this root 3 and root 3 gets cancelled. So 1 plus 1, or tan x equals to, okay, tan x equals to, there is 1 in the denominator, 1 into root 3 is root 3, root 3 into root 3 is 3, okay, are you getting me? The LCM of 1 and root 3 is root 3. So 1 into root 3 gives root 3. So root 3 into root 3 is 3. Root 3 into root 3 is 3. This minus comes here. Root 3 1 ja, this root 3. That 1 into 1, isn't it? So 1 into 1 is 1. In the denominator we have 1 plus 1, that is 2. So 2 upon 1. Or tan x equals to 3 minus 1 is 2 upon, we have root 3, isn't it? So this 1 goes up to the numerator into 1 and this 2 comes down to the denominator. So 2 and 2 cancels. So tan x equals to 1 upon root 3, 2 cancelled, 1 upon root 3, 1 upon root 3, or tan x equals to 1 upon root 3 means tan 30 degree, isn't it? So leaving tan from both the sides, x equals to 30 degree. Okay, this is the process, this is the method you should be using in class 10. Otherwise you could have done in the easier way, isn't it? Question number 5 of 7, find the value of x. Sin 2x equals to 2 sin 45 degree cos 45 degree, isn't it? Very, very simple question. Sin 2x equals to, this 2 I write here, sin 45 means 1 upon root 2 into cos 45 means 1 upon root 2. Okay, so sin 2x equals to 2 1 ja 2, 1 ja 2, 2 is in the numerator, in the denominator root 2 into root 2, 2, okay, root 2 into root 2, 2, root 2 into root 2, root 2 into 2. So make the pair and take it out, free from the root 2, isn't it? Similarly root 3 into root 3, 3, root 4 into root 4, 4, okay. So this 2 and 2 gets cancelled, 1 remains here. Sin 2x equals to 1 means sin 90 degree. Sin 90 means 1, or let us leave sin from both the sides. 2x equals to 90, or x equals to 90. This 2 goes to the denominator. 2 1 is 2, 2 45 is 90, or x equals to 45 degree, isn't it? So this is the answer for question number 5 of 7. Okay, question number 6 of 7. Okay, sin 3x equals to 2 sin 30 degree cos 30 degree, isn't it? So, or sin 3x equals to, this 2 comes here, sin 30 means 1 upon 2 into cos 30 means root 3 by 2. So this 2 and this 2 cancels. Sin 3x equal to root 3 by 2, isn't 2 and 2 got cancelled. 1 into root 3 is root 3, root 3 by 2. Root 3 by 2 means sin 60 degree, or 3x, leaving sign from both the side, 3x equals to 60 degree, or x equals to 60 upon 3. 3 1 is 3, 3 2 is 6, 0 is 0, or x equals to 20 degree. Okay, I hope you got this. 3 2 is 6, 3 0 is 0, x equals to 20 degree. For 7 of 7, okay, find the value of x. We are asked to find the value of x from this equation. So we have cos 2x minus 6 in the left hand side, and in the right hand side we have cos square 30 minus cos square 60. So let's do this. Cos 2x minus 6 equals to, cos 30 means root 3 by 2, isn't it? So cos square means we must put square, minus cos 60 means 1 by 2, square means we must put square here, or cos 2x minus 6 equals to, so root 3 square is 3, 2 square is 4, minus 1 square is 1, and 2 square is 4. Or cos 2x minus 6, since the denominator LCM is same, isn't it? So 3 minus 1 is 2 upon 4. If the LCM, if the denominators are same number, you can directly subtract like this, or directly add if there is plus sign. 3 minus 1 is 2. 2 1s are 2, 2 2s are 4. Or cos 2x minus 6 equals to 1 upon 2 means cos, 1 upon 2 means cos 60 degree, isn't it? Cos 60 degree. So cos and cos will leave this from both the sides. 2x minus 6 equals to 60, or 2x equals to 60 minus 6 will take to the right hand side, plus 6. Let me continue here. X equals to, or x equals to 60 plus 6 is 66, isn't it? 60 plus 6 is 66. This 2 goes to the denominator. 2 1s are 2, 2 3s are 6, 2 3s are 6. Or x equals to 33 degree. Okay, let me write properly. Okay, 33 degree. So this is the value for x. Thank you so much for watching this video. I'll continue the remaining question in the next video. Okay.